Alright, Assalamualaikum, very good morning. So we are going to start class, eh? So as usual, when we start class is that go to Ulearn, my Ulearn, and then we are going to look at the week where we are right now. So we are at week 2. So in week 2, if you see here, there's no changes. So if there is no changes, then meaning that the activity will be the same. So basically, manual tick your attendance, okay? Even for today, so click here for the attendance, okay? Just click here as normal what you did previously. Sorry, okay, this one. So manually click your attendance. Let me just edit that. So week 1, 2. Okay, because if I don't edit that, then you won't do the attendance, eh? So yeah, I just edited that. So please go to week 2. Okay, manually tick attendance. Is that attendance? This one. Open. I think I edited. Anyway. Sorry. That's my course. Okay. You click on this, the attendance, and then you can just click there. All right, so let's look at the attendance yesterday. What for yesterday? Okay, for yesterday attendance, apparently only 25 students did the attendance. But I noticed that for the week feedback form, the attendance, it's 54 students who actually answer feedback form. So please remember to all students, okay, attendance is compulsory. Normally, if we are in class, I'm going to pass you the attendance, then you tick it manually. So it's same thing, just that you're going to do it on your own via the attendance link. Okay, so please make sure that you do this. The reason why you may ask, okay, because student is like this simple task pun you don't want to do it, eh? That's like attendance, and then you say that I'm taking the feedback form for the attendance. So why I need to do both? Okay, reason why I need to do both is that for the attendance, this one, later on, by the end of the semester, I'm going to actually export the report of this attendance for the ISO. So if the attendance here does not reflect to the student who attended the final exam, then I need to answer to the auditor. All right. So please help me, okay, by doing the attendance. Please be responsible on your own. You are a student, adult student, basically. Adult student, you are 20 years old and above. So please do this attendance. Okay, I think I do not need to repeat it again. So let's see for the attendance right now. Okay, normally to force students to do the attendance is that I need to show who didn't do attendance. So Azfar, see, okay. Alfa, Darwisha, Ibrahim, Hafizuddin, Khairunisa, else? The red one lah basically. Okay. Muhammad Amirul Nizam, Muhammad Aiman bin Muhammad Shahar, Muhammad Fakrul Shahmi, Muhammad Hafiz, Muhammad Shahrul. Okay, this is the reason why actually ULearn is only to be entered by my student, because if different section enter my ULearn, then their name also in my section, so it's very hard for me to filter. But anyway, and that's another job for me, okay. So Nur Farisha, Nur Zafira, Seo Wing Kyung, I'm not sure if he is in my class. Anyway, and Zulukman. Okay, so please make sure that you do the attendance. Also for this week, make sure that you do attendance. Okay, and then we go through. So it means that for week 2, we have 2 classes, kan? On Wednesday and on Thursday. So every day, okay, if I say that it's synchronous class, then go to the week 2, what week you are right now, and then go to the instruction. If there is new instruction for that specific day, then just follow it. Okay. If it's general, then it's general lah. So today is class online activity. We are going to use the same Padlet. Okay, and you will see that for week 2 is that I actually have 2 class reflection, which is yesterday. You have done that. Okay, thank you very much for those who have actually give the feedback. And I would say that most of you guys would prefer that I maintain the normal pace, the same pace for the next coming class. Okay, I will try to do that. And there were comment by student who say that I think one student sajalah yang commented prefer using Teams. Unfortunately, I don't like using Teams because it's not actually the official platform for student learning. If you see, comparing Teams with ULearn is actually designed for student learning. You see, actually, I can give you quizzes, a lot of activity in the ULearn in compared to MS Team. So, and it is more organized for me. And I think it's more organized for student, means that you can see what weekly, what we have activity and the link and so on. Okay, so I would prefer ULearn. Okay, and for the platform of synchronous classes using WebEx, since I have actually used MS Team before. Unfortunately, lagging like once 10 seconds and so on. So sometimes the screen freeze and so on. So like I said in Telegram, I think to the student that commented that, sorry that I cannot use ULearn to cater only for you, but you need to actually adapt to the WebEx. WebEx is very easy. Okay, you either can join via the link that I show to you here. Just click this, it will open the browser, or like I mentioned that download the WebEx apps. Okay, how does the WebEx apps look like? If you see here, okay, this one, yeah, this is the WebEx apps. If you download it in your desktop, okay, you download as a desktop version. Okay, of course you can download in your handphone, but I don't think you're going to learn much if you look at your if you have classes via your handphone. Yeah, it's very small. So I would suggest, I think by this time you are a second year student, try to buy a computer or second-hand computer or second-hand laptop. Okay, I think it's roughly about 1,000 ringgit. You have your PTPTN, or you have your own scholarship. So try to buy at least one laptop or PC. Okay, so install this desktop and then you will see that this is basically very simple. Okay, I have my schedule here. Right now we have the class. So when we have class directly, I can join it. Or if for your case is that for the student, if for the student, because I share to you the link, the link here, okay. Might be boring for some student because this one is, I think, should be by now all students already know how to use a WebEx. So if you do not know, then let me just explain it. So I have given to you on lesson 2.2 how to join WebEx. Copy, Control C in your keyboard, Control C that, and then Control V that. Okay, so you can join directly. Okay, when you join that, it will ask you for a password. Then use this password. Okay, or you can directly copy this, Control C the link, and then also paste it in the join a meeting. So there are 2 ways to join the meeting. Okay, If you join it by link, it will directly jump to enter the WebEx, okay, without any password. So every week we have the same meeting number, password, and link. So I would say that for the student that commented yesterday, maybe week 1 you didn't enter my class or you didn't join my class. So that is unfortunate. So try to adapt to that. At least I'm showing you how to join the WebEx. Yeah. Okay. Semua dengar macam sepi je. Okay. Anyway, let's start with class. Okay. So yesterday class, we did the transformation, signal transformation, which is you have done on the time reversal, time scaling, time shifting. Okay, so hopefully that all of you remembered, because you have done the activity using Padlet and you have uploaded, and I saw that the activity using Padlet. Okay, let me just see the Padlet. Padlet. Okay, this one. All right, the activity here. Okay, so week 2, we are in week 2. All right, so the activity, the first activity was here. Okay, very good. But I would say that not all students uploaded that. Okay, I have 52 students or 53 students attending my class yesterday. Okay, please upload it. Okay, I wouldn't say it's compulsory. But if you upload it, then I know you understood the class. If you do not upload it, means that it's either you didn't do the activity or exercise, and this will impact to your midterm and also final exam. Right? I'm saying this truthfully, okay, reason why students fail the subject, especially subject signal system or mathematics subject. Reason why is that they do not have enough practice. Okay, so practice, where you need to practice is that I give practice in class. Okay, during the tutorial, I give you exercises. So this is, you have 2 hours with me to commit to these exercises. Okay, if you cannot even commit during my classes, what do I expect from you if I give you the tutorial? Okay, I have uploaded tutorial in ULearn. Okay, the tutorial. Yeah, hopefully by now, okay, student have gone through my ULearn. Okay, if you see my ULearn, I actually changed the photo and so on, so that to make it much more interesting. So you can see that we have the group where you have chosen the group. Okay, then we have the assessment where we have the attendance as the feedback over there. Okay. And we have the forum. So forum is somewhere other than the Padlet. In the Padlet also, by end of every week, I will actually ask which part you do not understand. So you can actually jot down here in the class, or here week 2. And okay, there's one person who actually asked me for the recording, so I already comment that. Okay, so very good for those students who actually join my activities in class. So I know that you are there with me. So if you are not even commenting or not even uploading anything in the Padlet activity, so you might be lost somewhere. So and kebarangkalannya, the statistic of you failing this subject is really high for that reason alone. Okay, so please go through the ULearn tutorials. Tutorial 1 I have uploaded, okay, and you will see that I have uploaded 10 questions for chapter 1. Okay, 10 questions. And tutorial, I won't actually ask you to submit it, but in my notes, I have mentioned that do the question 1, blah, 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 and so on. So you need to do it on your own. Okay. And as a group, as a student, okay, reason why I share to you in Telegram the video of how to be a successful student and so on is that students who are very good, okay, who get very good grades every semester get A or A minus or B plus, is that they actually do more than they are supposed to do. Means that during class, they will, of course, they 100% join the activity. And before class, they do a pre-read. And after class, they do a post-read or revision. So revision means that whatever tutorial like given by the lecturer, okay, you can do it on your own. Okay, this is very simple. You're given a signal. Okay, do the sketch for the time and amplitude transformation. Okay, so please do it. Okay, we are not in high school anymore. For me to sit down and then entertain you for the tutorial session. I have incorporated in the class, but not all, since we cannot cover everything. Okay, in one go. So back to that. Okay, so make sure that student know how to be a student. Okay, I think it should be you should know by now, your second year, how to study, how to actually score for exam. You need to have a study group. Okay, this I always tell my academic advisor student. Okay, a study group is really important, even though you are online like now, but you can have a study group online. Do your own study group via WebEx, or even you can do it using Google Meet. So it's up to you. You can be creative outside of my class. Yeah. So find a study group where you sit down together and discuss on the tutorial. Okay. If you think that doing alone is boring, then find a group to do it together. All right. So back again to the summary. So you have done on the time reversal, and then you have also done on the amplitude transformation. So we have done on the amplitude reversal, scaling, and shifting. So I think most of the students commented yesterday. They say that okay, they are clear about it, but a bit confused on the because we have for time transformation, we have two types of method. So as mentioned, we have method 1 and 2. But a reason why I show the method 2 is because there were some students who used that method. And unfortunately, using the method, if you do not know the steps, the procedure, then you won't get the correct answer. So very easy for time reversal step. Do the first step, which is the time transformation first. And in my notes, I have actually done, okay, do tutorial 1. You do the tutorial for question 1. Okay, A, B, C, D, you can do it. Okay, 2, question 2, A until E, you can also start to do that. Okay, so homework also, you take home homework. You can try to do these exercises, very simple signal, and do this transformation. Ada homework 1 and 2, and lastly was tutorial 1, question 1 until 6. Okay, please do it. Actually, I should have asked you to do it yesterday, but I forgot about that. But anyway, it's in your note. Okay, so right now we are going to continue with the part 3, which is on the. Boleh dengar? Everyone is listening. For some reason, it's very quiet. Boleh dengar? Okay.
Yes, Doktor. Boleh dengar, Doktor.
Hello.
Hello, Doktor. Itu Doktor yang tak dengar kami ya.
Okay, I'm listening. All right. Thank you,
Okay,
Shakirin.
okay.
So next we are going to go to the part 3, which is transformation of the independent variable. So as mentioned in week 1, I explained about periodic signal and continuous time for the continuous time signal. So periodic signal is something that is continuous. Okay, continuous signal. So example of periodic signal will be a sine wave. Okay, sine wave. So this is sine wave. Another signal will be a cosine wave. Okay, cosine wave. So this one and continuous time means that you will see that the signal is actually repeating, vice versa. So this example is actually a sample of a continuous signal which reflect a rectangular waveform. Okay, rectangular waveform where it has amplitude 1 and it goes to 0. Okay, Of course, you can have a continuous time signal that which looks like this. So you have the plus and minus. Okay, so this also represent a continuous signal. So you have plus and minus amplitude. Okay, just save that first. Right. So, and in contrast to the continuous signal, okay, we also have the discrete time signal. So, as what I mentioned in last week class, we have two types of signal. We have the continuous time signal and we have the discrete time signal. Continuous time signal is represented by, if you are representing it by x, so it's going to have in a bracket t. Okay, so you know that it's continuous. Okay, and for the discrete time is that you will have x also for the signal x, but in bracket n. Okay, so it's in integer. Okay, so that are the difference between the continuous time and discrete time signal. Okay, so same to the continuous time signal, it also have a period signal. So example here, okay, I forgot to explain that. Okay, example is that you have the periodic fundamental period T naught. So for example here, if let's say we take a T naught is equivalent to T. So every T second is going to repeat the same signal. So if you see here, okay, let's look at this signal. Just erase that. Okay, so let's look at this 0. Okay, 0. And then this here, it says that you have the fundamental period is T. So T is the fundamental period. So meaning that this is T, okay? So every T cycle is going to repeat again the same period. So this T value, this is T period, okay? So next T period is going to repeat 2T and then 3T and so on. So you will see that it's going to repeat. And if that signal is repeating until infinity or minus infinity, means that that signal is a periodic signal. Okay? And same goes to the discrete time. So for the discrete time is that you are represented by the value n here. Okay, for the fundamental period and here for the case of it is equal to 4. So meaning that every 4 integer, okay, is going to repeat. So you can see that it's 0, 0, and then minus, minus. And back again at the point 4 here, figure 4 is going to repeat again the same signal. Okay, then it will start again. Okay, for example, it will start again. Okay, and until infinity. Okay, same goes to the minus part. Okay, so this is what it means by the periodic signal. It's going to repeat infinity. So if you see that a signal is not repeating, for one cycle is one signal and then next is different. So that is not a periodic signal. This is really important to understand the concept because in chapter in Fourier series and Fourier transform, there's a different method why you need to use some signal, you need to use Fourier series, and some signal you need to use Fourier transform. Okay, but that will be explained later on. Okay, and next is we go to the even and odd signal. Okay, so what are even signal and what are odd signal? Okay, so even signal means that the signal is symmetric. Okay, symmetric. So assuming that, let's say, I give you, what's my, okay. Okay, let's say, okay, symmetrical. We have a piece of paper over here. You have a piece of paper over here, and then I actually draw a line in the middle. So if it's symmetrical, means that if I fold it, it's going to overlap perfectly with each other. Okay, so this is what it means by symmetrical. Let's say the line over here, the center part is actually at t equal to 0. Okay, so t equal to 0, if I fold it and it overlap perfectly, then means that it's an even signal. So taking that concept is, okay, so you see that we have xt here. Okay, you have learned yesterday that we have normally signal will be represented by xt. Okay, signal or anything. You can have zt. Okay, it's just a labeling. Okay, xzt, yt, and so on. Okay, so for an even signal means that xt is equivalent to x minus t. So what it means that the t value here, this is what? This is time. What transformation is it for this signal? Can you answer that in the chat or you unmute your mic? What is the time transformation? We just learned it yesterday. What's the time transformation for this? Okay, good. Muhammad Ridwan, time reversal. So it's time reversal means that because you have at t there, you have the minus symbol, kan? So meaning that, you know, yesterday you have learned about when you have something that is on the right side, so if you have a reversal, that is going to be flipped at the negative part. So means that it says here that xt is equivalent to x minus t. So that what it means that, okay, if I were to draw this value again, this is don't look at that yet. Okay, don't look at that yet. Okay, so xt. Okay, so let's say that xt we have here, this is xt. Okay. Uh, it's my note. Okay, this one. Okay, the signal is given by this one. Okay, for xt. So let's say this is xt. So I draw it xt. And it says that xt, if it's an even signal, then xt is equivalent to x minus t. So meaning that you have this signal being reversed here, right? So you have another signal which is on the left side like this. Okay, so if you have this type of signal, then meaning that it's going to be an even signal. Okay, this is what it means by this equation. So I actually just explaining the equation right there. Okay, and same thing goes to the this is continuous time, and this is discrete time signal. Okay, so for discrete time signal, also the same thing. Okay, let's say that for an even signal, you have here at 0. So we have this type of signal. Okay, so means that this is 1 and 2. So if I have this one xn, and it says here xn is equivalent to x minus n. So I have it reflected here at the negative part. So I have minus 1 and minus 1 and minus 2. So this will show to me that, oh, okay, this is an even signal. Okay, so this is the definition of this equation over here. And for the odd signal, same concept. Okay, so for the odd signal is that it's anti-symmetrical signal. So means that Okay, let's look at this. It says here that you have minus xt equivalent to x minus t. Okay, so it says here that you have here is going to be anti-symmetrical, means that it's actually symmetrical on the left side, but it's going to have the minus amplitude over here. Okay, so this is example of anti-symmetrical odd signal. So example of odd signal, if I show to you this example, okay, even signal. Example of even signal is the cosine wave. Okay, an example of the odd signal is actually sine wave. Okay, so let's look at the transformation of for the even and odd signal, the transformation or equation of the even and odd signal. So for the even signal is actually the product of two even or two odd signal. So what it means is that, okay, if you are given a two even signal, okay, and you add it up, you will get an even signal. Or if you're given two odd signal, if you add it up, you will get an even signal. So that is what it means. Okay. And xe here, okay, xet is equivalent to, okay, xe is e means even, is equivalent to xt. So you have the original signal xt just now plus x minus t, which is you flip it, okay, at the t value and divide by 2. So you will get the even signal. Okay. Or for the discrete time, you are given by the same signal, just that in terms of bracket over there. Okay. And for the odd signal is that the product of an even and odd signal. So we have x even equivalent to xt minus x minus t over 2. So the difference between the even and odd signal, okay, is the symbol here, plus and minus signal. The rest is the same. Okay, so even signal you have the plus sign, and for the odd signal you have the minus sign. Okay, so if you understood that, maybe not 100% understood, but later we will I will explain it using a signal so that you will understood how to prove it. Okay, so third one is that any signal which is continuous or discrete can be expressed as a sum of even and odd signals. So okay, you know right now, okay, you have the original signal xt. What happened that you try to find out what is x even and x odd, right? And then underneath here, the third description was that any signal can be expressed as the sum of even and odd signal. Means that later on, okay, you found out that xt is actually x even plus x odd. So this is what it means. Okay, so for the sum is xt equal to xe plus x naught, or xn equal to xen plus x naught. Right? So let's look at this example. Okay? Prove the following equation is true for xt. Okay, so you are given the equation xt. Okay, you have the even signal equation is given by this, and you have the odd given by this. Okay, and later you need to prove it. Prove it. The question was prove that the following is true for xt. So means that you need to prove it that xt is equivalent to x even plus x naught. Okay, so to do this proving, you can see that this one, okay, xt, you have the x even and x odd. So what you need to do is that first step is get what is x even, okay, the signal, and then solve for what is x odd, x even, x odd. So when you have these two, then only you can prove that xt equivalent to x even plus x naught. Okay, so let's do that example. Good job. too big. It's smaller, right? Okay, so to do this proofing, okay, so to do this proofing, take out the equation over here. Okay, just take that. Oh, sorry. Okay, I'll just write that. Okay, let's write together. So you have x even equivalent to, okay, x. Write together. If not, you get bored watching me write. So you have from this equation xt plus x minus t over 2, right? So you have xt plus x minus t, okay, and then and I prefer to write like this, over 2, okay. So meaning that, okay, so I know that, oh, okay, directly I can see, oh, xet is equivalent to xt, means in the original signal, plus x minus t. Okay, after I add that up, and then I'm going to divide the amplitude by 2. Okay, so meaning that this one is for odd. Okay, and for even, for even, and for odd is x odd is 1 over 2 xt minus x minus t. Okay, so this one is for odd. So this is even, this is for odd. Okay, so let's do first for the xet, for x even. So x even, okay, if I look at this equation, okay, I'm going to draw out for xt first. Okay, so draw out xt. xt, okay, and then you have, you can see that here you have t, and then you have 0, minus 1, 1. Okay, so you're going to draw out this signal. So you have 1. So this one is amplitude 1. So this is for xt. Okay, xt. So I'm going to write here, maybe somewhere here, xt. Okay, and next step is that you see that you have the x minus t. Okay, so you're going to draw out the x minus t. T. Okay, then you have 0, minus 1, 1. So x minus t, what does it mean? Means that this signal is flipped, kan? Flip at t equal to 0. Flip at t equal to 0. So means that if I draw that out, I will get this signal. Okay, okay, I will get something like this signal. Okay, and from this equation xe over here, this xe equation, okay, you see that you have xt plus x minus t. So what you're going to do is that, okay, you're going to actually add these two equation. Okay, so if you see here, this is actually represented by this equation. Okay, this one. So you're going to find the x e t, right? So what you have here is that, okay, draw back again. So we are going to draw it underneath here, t. Okay, so we are going to draw x e t. Okay, actually it's not the xet over the correct one, but okay, if you were to rearrange this equation only, so these two will be going up here. So you have 2xe, and So basically, it's actually you're going to get 2x even. Okay, so this one is 2x even. So draw that out. Okay, just add up everything in terms of the amplitude. Okay, so you have 0 amplitude plus 1. So you have 1. 1 plus 1, you have 2. 1 plus 0, you have 1. So you have something like this. Okay, so you can just put that so that you won't get confused, the amplitude value. So you have 1 there, 1 here, and you have 1 and 2 over here. Okay, so this is the value, but you have not actually answered the proof for the equation. The equation just now is that to prove x t equal to x even t plus x odd t. Okay, so you need to find what is x even. This one, x even. So just now what you write here is actually, okay, here, this one, yang ni, 2xe kan, because you take the 2 over here and you get 2xe, so 2xe. So what you need to do is that you need to divide the amplitude, signal amplitude over here. 2xe is there, you learned yesterday about the amplitude transformation, right? So what it means that you divide it by 2. Okay, so what you have here, I'm not going to write it again. So just let's say that I'm going to slash that out. So I will get 0 0.5, 1, and 0 0.5. Okay, so this will be the final signal value. So if I were to draw that out, okay, for x et, okay, you will have 0 minus 1, 1. You have the signal, something like this. And then you have the value 0 0.5, 1, and 0 0.5. Okay, this is for x even. Okay. Any question on this? Any question, guys? No? Okay, you might want, I'm not sure if in my class right now there is other student who actually taking from other lecturer. Okay, the way I explain is different. Okay, I do not use table and so on. Okay, I'm more to graphical method, and it's much more easier so that you student can understood what happened to the signal. Okay, if I'm using table, it's okay. If using table, actually whatever that I teach right now, you can actually transfer it to the table, but I'm not going to do both. So graphical method is for student to actually imagine, and based on the original signal over here, they can actually imagine, oh, okay, this is what happening to the signal, and that's why you get the end signal of xt over here. Okay, guys, are you there? Because it's quite silent. I'm not sure if. Hello. Okay. Yes.
Yes,
All right.
Doctor.
So okay, everything is okay. If everything is okay right there, okay. I understood. Understood. Okay, just right there, understood. So that I know, because if you don't understand this later on, it's kind of I'm going to, if I'm were to going to repeat it, then it will take time. Okay, so hopefully that everything is understood. Okay, next we are going to go to the X odd signal. So X odd signal. So we are going to do this signal XOR. And similar to what you did in the X even, okay, I'm going to move with this above. So we have 2x0. So what you have here is that you are going to actually draw out the same thing, x minus xt and x minus t. Okay, for that reason, okay, I'm just going to copy this. Oh, sorry, it's not copying. Okay, anyway, tak apalah. I will draw it again. So I have here x0, so xt. you have xt, so 0 minus 1, 1. You have t value and draw it, the value for xt. So draw xt. So, and then you're going to draw out x minus t, same signal. Okay, 0 minus 1, 1. So it's going to be the inverse of that. Okay, and you have seen that what you have here is that, okay, the equation here is xt minus x minus t. So you have here the positive signal and you have negative signal over here. Okay, so it means that you are going to subtract the amplitude value. So here you will get x naught t with the two value over here, which is this one. Okay, so let's do that. So t value, so you're going to write that 2x naught t, okay, with the 0 minus 1, 1. So right now, let's do the subtraction of the amplitude. Okay, 0 at minus 1, t equal to minus 1, 0 minus 1, what do you get? Minus 1. 1 minus 1, you get 0. 1 minus 0, you got 1. Okay, so you will get something like this with the amplitude, okay, minus 1, 0, and 1. But you have to remember that you have the t value here, so you're going to slash that out. Means that you are going to divide the amplitude by 2. So in the end, you will get 0.5 minus 0.5, 0, and 0.5. Okay, so if I were to draw out x naught over here, okay, we have x naught, x odd. So you have 0 minus 1, 1. So it will look like this. 0.5, 0, and minus 0.5. Okay, so in next step, sorry. Okay, so next we are going to look at the, it's my pen, this one. So the question was, prove the following equation is true for xt. So we have xt equal to x even plus x naught. So what you need to do is that you need to prove that x even plus x naught equivalent to xt. So x even, just now you have the equation, the signal is yeah. So we have here xt equal to x even plus x odd. Okay, so just now you have x even is given by 0 minus 1, 1. Okay, x even you have, it looks like this just now. Okay, 0 0.1, 0 0.5, 1, and 0 0.5. So this is x even. Okay, and you have x odd at 0 minus 1, 1. Okay, so x odd, it looks like this. Minus 0 0.5, 0, and 0 0.1. Okay, so looking at this equation, so you actually need to add xe plus x naught just now. Okay, so you have x odd. So just add that plus minus, plus together, then you will get xt. Okay, notice that, okay, notice that in my explanation, actually, I'm rowing all of the xe, x naught just now in the same axis. Okay, align. Okay, notice that even for the x even just now, I draw it align. Okay, because I noticed that a student yesterday when I explained to you in one line, so that every time T0 will be at the same line position. Okay, one is it's easier for you to actually add or subtract later on. Okay, and you won't actually mistake when you do some subtracting and so on. Okay, scaling and so on. So I would suggest when you answer in your final exam, make sure that you draw it aligned. Because yesterday I noticed that some students are answering in this way. They draw the first signal like this, and then next signal is like this, and next signal is like this. Okay, I didn't teach you like this. Okay, this is you draw on your own. But remember, when you want to add on or you shift something, you might shift it at a wrong position because it's not aligned under the same t value. Okay, so how I explained to you was in this direction, kan? How I explained to you was to draw it in this direction. Okay, so means that it's aligned. So that's a tip from me because this is where student will always make mistake in midterm or final exam because of when they do not actually draw it aligned in one axis, the t value at t equals 0, then at one step they did wrong, then the rest will actually go wrong. Okay, so this is where student need to actually follow what I teach. Okay, so that this is actually the tips. I teach you the easiest way, the one that you did in that horizontal position, across like that is actually is okay, but if you get it wrong, then I'm sorry for that because that will be a mistake from your side. Okay, so back again to this equation. So xt is equivalent to xt xe plus x odd. Okay, so what you need to do is that same thing what you have done in the x even x odd. Okay, label it 0 and 1. So you are going to add the amplitude. So at -2, there's no value, right? So just ignore that. You can just put it 0. Okay, so next we go to at t equal to 1 here. Okay, so we have at 0.5 plus minus 0.5. So means that what? So 0.5 plus minus 0.5, so you get 0, correct? 1 plus 0, you get 1 plus 0, you get 1. Okay, and 0.5 plus 0.5, you get 1. So this is the value of xt. So did you actually prove the original signal here? Yes, you actually prove the signal of xt over here. So this is the method on how to prove. Okay, normally in a signal, in a exam midterm, they will actually give you one signal and prove that the even and odd is equivalent to the original signal. Okay. So this is one example. Okay, even an odd signal. Why is it here? Okay, so I think this should be actually explained in the beginning just now. But anyway, no worries. Okay, so which is even an odd signal. So as mentioned, the signal. Okay, this is a sine wave signal and this is a cosine wave signal. Even though you have the same sine signal over here, but you need to look at this part. Okay, remember yesterday you talked about shifting value, time shifting. So this is actually a shifting. Sine n over 6 is the fundamental frequency minus pi over 2 is the shifting value. So the shifting value is shifted at this position. So if you see this, it is an even signal. Okay. And in contrast to this, the B question is that you have xt equal to sine n over 6 plus pi. So you will see that there's a, I think this is not N and this is T. Okay. And then you have plus pi. So you see that this is representing a sign with signal. Okay. Okay, so let's do an exercise. Okay, this exercise, please go to the Padlet, okay, and upload your answer. So the question is, okay, sketch and label each of the following signal for even signal, odd signal, and then lastly is to prove that the signal using even and odd signal. Okay, so go to Padlet. Okay, let me just snapshot that. I'm going to post it Padlet, so I'm going to give you, now it's 9 okay, it's 9 plus with break lah. So I will add a new column here. Okay. Okay. So what you need to do, or the student, after you have done that, then just click on the upload button and write down as normal, write down your full name on the question and make sure that when you take a photo, don't take a photo of your keyboard. Okay, like similar what you did in your final exam. Okay, final exam and midterm exam, what you do is that using a scanner, scanner or using your camera apps. Okay, that's a tactic on how to take a photo. Okay, you see that taking a photo using camera, make sure the camera is aligned with the paper. Then you will get a very sharp detail of your answer. Okay, only taking the paper, the picture of your photo. Wow, ada benda ni pula. Sorry. Anyway, yep, I remove that. Okay, 5 minutes. Sorry, 10 minutes until we will come back at 9:15. Okay, thank you. Right, have you finished? Let's look at the... Yeah. So I see that you have uploaded the answer. So I think should be okay. Okay. I'm not going to discuss it with you guys, but the answer, if you can prove, okay. Sorry. If you can prove again, so the first step is for this exercise is that to draw out the even signal. Draw out the even signal. Okay. And then draw out the odd signal. And then lastly is to prove the signal is xt is equivalent to x even plus x odd. Okay, if you add these two signal and you get back the original signal, then your answer is correct. That's all. Okay, so it's very easy for this. If you can prove it's the same, then it's going to be this the correct answer. Okay, same thing goes for this question. This type of question is example of the discrete time signal. Okay, so similar concept. Okay, I think you can do this at home, but I'm just going to explain this part. So if you see here, okay, xt is equivalent to 1 for n equal to 0 and for 0 for less than n. So if you see here, let's say that I do not have this signal here. Okay, I'm going to draw out the signal based on this equation. So if I draw this out, so I have n here, okay, and I have value from 0, 1, 2, 3, 4, and until infinity, and then I have -1, -2, -3. So if you read carefully the equation, you see here that there's it says that xe equivalent to 1 for n equal to 0 or more than 0. So n equal to 0 or more than 0. So means that it's actually you have a signal until infinity for from 0 until infinity. And for the rest, less than 1 is you have 0. Okay, but just to prove the concept of this exercise is that you're going to use this equation. Okay, so do not look at this. Just look at this signal given. So answer xn equivalent to x even plus x naught, and you can, if you can prove that, then you have the correct answer. Okay, this amplitude, if in exercises or even in your tutorial or midterm, if it's not given any value for amplitude, then it's assumed 1. But anyway, you can always ask the lecturer what's the amplitude if it's not given. So amplitude is 1. Okay, so I would assume, okay, later on, okay, I will add another column over here for the I will add another column here for the discrete time exercise. So discrete time exercise. Okay, upload here. I will upload the exercise here. For now, I will just directly, we will continue with the chapter. Okay, so for homework is that try to answer for the tutorial question. For question 1, 2, and 6, if you go to the tutorial over here, tutorial 1, so okay, tutorial 1, okay, the question was to answer question 1, even and odd. Okay, so right now, because we have reached until the even and odd, so right now you can already answer for question 1 full A until G, okay, number 2 A until H, And then for number 3, 4, you have not learned it yet. So just ignore that first. And then 5 point also you have not done it yet, so don't answer that yet. And question 6, you can answer that. This is on the discrete time signal. Okay, so even and odd. So you can do the try to answer for 1, 2, and 6 at home for this weekend. So we are going to go next to the part 4, which is on the exponential and sinusoidal signals. Okay, so complex exponential signal is given by this equation. Okay, as you know, exponential signal is given by exponential value. So xt equal to c EAT. Okay, so c is actually the magnitude of the signal itself, and a is the complex number. So it means that what is the slope of the exponential signal, and it can be given by this type of equation. So if you were to have an example of signal, okay, so growing exponential signal, signal or exponential signal is when you have a more than 0. So looking back at this equation, okay, C is referring to the cross-sectional at the y-axis here. Okay, y-axis. Okay, y-axis. So C is this cross-sectional over here. Okay, and A means that A more than 0. So means that if A is 1 or A is 2, A is 3, then it's going to exponentially growing up. So meaning that, example, if I were to write out xt equivalent to 2e1. So for example, A C is 2 and A is 1. So 2 t lah. Okay, so it looks like this. So you have the magnitude at here 2, okay, cross-sectional, and you are going to have exponential over here. So you can have a different type of signal also. You have 2e2t. 2e3t means that the higher the a value, then you are going to have a higher slope value. Okay, so this is what it means. And for the decaying sinusoidal signal for xt, okay, or exponential signal, because sinusoidal signal, exponential signal, so you have a less than 0. So it means that it's going to be reflecting, okay, reversal of what value that we have for the growing signal. So C will be the cross-sectional, and the value, if A is minus, so means that for A minus 1, A minus 2, A minus 3, so it means that it's going to reflect in this. Okay, so example, it can be xt equivalent to 2e minus t, 2e minus 2t, and so on. Okay, so this is an example of exponential signal. Okay, we go to the what are the differences between magnitude and phase representation. So why you need to understand this one is because later on in the Fourier series and transform, you're going to use this. So we are going to understand what is the difference between rectangular form signal and the polar signal. So a rectangular form signal is given by this same equation. So you have sigma plus j omega. Okay, sigma plus j omega is a rectangular form. So imagine that you have this axis, you have the real axis and the imaginary axis. Okay, so you have also means that for the real axis, you have here sigma, okay, and the sorry, wrong. So here you have omega, and then you have sigma. Okay, how you read this is that this is the coordinate can. So you have sigma. So sigma represented by this axis. So sigma is this value, and omega is this value. So if you were to write that, you can actually write it over here or over there. Okay, anyway, I'm going to write it like this. So you have alpha here and omega here. Okay, and theta is represented by the angle with respect to the x-axis. Okay, so from here is that if you look at this equation, okay, let's say that we take out the rectangular form, yeah? So we have sec equivalent to sigma plus j omega, okay? So rectangular form is given by this value. So you have the imaginary value and the real value, okay? So what you need to do is that if it were to represent it in terms of a polar form, so what happens that you want to either represent it in rectangular form or polar form, so you know that you can use a calculator to actually convert between the polar form and rectangular form. But a rectangular form is that represented with the coordinate, and by polar form it will given in the terms of angular, okay, angle. So for this case is that you're going to find out what is theta here. So first of all, let's let me just write it over here. So we have cos theta. Okay, cos theta, looking at this graph, so what is cos theta? What is cos theta? Guys, write that in the chat or unmute your mic. Hari ni, today nobody actually answer, nobody unmute your mic. Or is it that I cannot hear you? I'm not sure. So what is cos theta? Tak ingat. Sigma over omega. Okay, correct. Sivas, So it's sorry. Sigma over omega is not sine, Sigma cos theta. It's sigma over r, correct? R. This one, the hypotenuse. Okay. So you have cos theta is sigma over r. Sine theta is omega over r. Okay, so if you were to rearrange this, okay, you will get r equivalent to cos theta, sorry, sigma equivalent to take it sigma equivalent to r cos theta, and here you have omega equivalent to r sine theta. So from here, you can see that, oh, okay, you already have the sigma and omega, So you are going to substitute it here. Okay, sigma and omega. So substitute it in here. This one is in here. So you will get z equivalent to r cos theta plus j r sine theta. Okay, if you rearrange that, you will get r cos theta plus j sine theta. Alright, so this is actually what you did was to actually convert it to from the rectangular form to the polar form. So this is what you did just now. Okay, so to convert it from rectangular form to polar form. So using Euler relationship, this is the common equation. So Euler relationship states that for Ej theta is equivalent to cos theta plus j sin theta. So if you see here, this is represented by this equation. Okay, so if you substitute that, then you have, I continue here, sec equivalent to r e j theta. So end up you get the polar form here. Okay, so what you did was to get it from rectangular form to polar form. So later on, this type of signal you will use it commonly in the Fourier series and Fourier transform. Okay, but we are going to learn it in the chapter 1 for the types of signal. Okay, so next we go to the periodic sine wave signal. So this is just a fundamental introduction on the sine wave. So you see here that you have a sine wave signal, and is the sine wave? Do you think the sine wave is being shifted? Is there any time delay or time shifting in this signal? Anyone can answer in the chat, yes or no? Any time shifting? Yes. Okay, there's a time shifting. Is it a time advance or time delay? Okay, correct. Aikal by omega. Okay, is it a time delay or time advance? Okay, first of all, the question is that what type of signal do you think is its original? Is it cos a sine wave signal or sine wave signal? First question. Is it cos sine wave signal or sine wave signal? Cosine wave, It's a cosine wave signal, correct? Reason why it's a cosine wave is that you can see that I actually state here that this is actually at t equal to 0, So this is originally you have a t equal to 0, so it's a cosine wave, which is cosine wave is an even signal. So based on this signal, okay, it's actually having a time advance, okay, shifting advance because it was shifted to the it's not time advance, it's a time delay, because it's actually delayed to the back, delayed going back to the back side, to the right side, So if you see here, you have xt, the equation given is xt a cos omega t plus the shifting value. Okay, reason why the symbol is plus? Okay, you may ask, hey, but doctor, it's a plus sign. Okay, this one is the original equation. Okay, means that from there you may know that okay, it's actually being shifted to the right. So it's actually the value is by minus. Okay, because of shifting. Okay, so you have a cosine wave. A means that the amplitude over here, cosine wave, because it's cosine wave, and you have a shifting omega t plus sigma. So you have a shifting phase shift over here. So phase shift, it means that you can have, remember in the original phase shifting, okay, in the original phase shifting, you can see that there's a difference between this one, So it can be the original signal, you have a t minus t naught. So it can say that you have a value of, if positive, then it's a delay, and negative is an advance. Okay, so by having that equation, okay, so we are going to look at, there's a few terms that you need to know. So what are the fundamental frequencies? So fundamental frequency is given by omega naught. And how you can actually calculate this is that by 2 pi f naught. F naught is the frequency. Okay, so how do you actually calculate for frequency? You may ask. So T naught, okay, is given by 2 pi omega naught, and T naught here is also equivalent to 1 over F naught. So from here, you can actually calculate what is the omega naught. Okay, so and for the same repeating sine wave waveform is that you can actually repeat it with the value for n. And here is represented by 1, 2, and so on. So you have 2 pi f naught. So you are going to repeat it until infinity. Okay. So let's look at this example. Plot the following two sine wave signal on the same graph. So, okay. Draw out the signal. Okay. At 5 cos omega t, how does it look like? Okay, it means that for the first signal is that, do we have any time transformation? No, okay. But you have amplitude and transformation. Okay, amplitude scaling. So draw that. Okay, second signal x2, 5 cos omega t minus 60 degree. Okay, so draw that. Okay, degree, maybe you can just make a, just put the 60-degree shifting and so on. You can actually convert it into pi if you want, but anyway, just leave it like that. So draw that very quickly on your paper. Oh, I think you upload it in Padlet, so that we can look at it together. This one. This one. Wait. Yeah, upload your answer in Padlet. Wait a while. I'm going to update. Make a. It should be enough. Very simple exercise. Load it. Okay, so upload your answer under this one, Okay. So let's look at your student answer. If you have done that, very quickly screenshot it, save it. Okay, are you done, guys? Only do this task, the discrete time transformation later. Okay, this one only. Okay, if you cannot find my Padlet, actually, when I add more column, the Padlet will move to the right side, So you need to scroll down here. Take your mouse and scroll it to the right side. So, for all the 14 week, I will look at how we go later on. Maybe I will open a new Padlet, but anyway, from here is that we will actually synchronize all the activity into one Padlet. It's more easier for you to actually refer later on, So, anyone? Or not? If not, I'm going to explain it. Okay, because it's taking too long time. So let's say that we are looking at the F cos omega not t. So what you need to do for the first part is that, okay, you know that you have original is cos omega t. Okay, so cos omega t, how does it look like? Actually look like this. Okay, correct, with the amplitude 1. Okay, but because you have the amplitude 5, okay, so meaning that you need to have an amplitude of 5 here, so the signal will actually, I need to remove that. Very hard for me to draw it. Okay, so if you have, I have like this, so I can actually draw it. Okay, if you want to draw, you can just draw it very easily. You have pi, then you have 2 pi. Okay, so to make it a full swing, so okay, so let's see, I draw it something like this. Very bad. So if I were to look at one cycle, so one cycle is until this point only, okay? So I would like to write there 2 pi. So the full cycle, 2 pi is what, 360 degree, and so, and then half cycle is this here, pi. So pi is 180. So you have 5 cos omega t. So amplitude, you may write that 5, and then you can write it minus 5 here. So this one is answering to question A. Okay, so question A, if you are using different color, you can write there using like this lah. Okay, f cos omega t. Okay, I'm using another color, blue color font for the question D. So f cos omega t minus 60. Minus 60 is a time shifting, okay, which is time delay. So you're going to shift it by 60 degrees. 60 degree, actually, okay, pi you have 180, kan? So pi 180, so divide by that, you have 80 degrees. So half of it is 80 degrees here. So roughly we have 60 degree over here. Okay, so based on that, you know that you're going to shift everything. Okay, you want to shift the 60, the signal by 60 degrees. So I'm going to eyeball that shifting. Okay, so the signal is being shifted by 60 degree. Sorry. Should refer to this. Look at this, shifted by 60 degree over here. So you're going to shift it. Okay, so it means that this is shifted by 60 degree. Okay, with the same value of amplitude 5. Okay, so roughly like that. If you have at home, you have a ruler, it's much more easier if you can use a ruler to actually label the amplitude and shifting value. Okay, lastly, because we don't have time, but I'm going to close it with the next slide. Okay, is on the period and frequency of the signal. So as you know, a sine wave signal is going to be a continuous time signal, and a cosine wave is also a continuous time signal, and the effect of frequency is actually will actually affect the frequency, will actually affect to the signal. So you can see that, okay, based on this value T0, you can actually manipulate the signal frequency by changing the time. Okay, the T, the period, frequency, period. So it means that you change the fundamental period T0. Okay, so if you see here, between signal 1, 2, and 3, you have higher frequency for this first signal, and you have lower frequency for this third signal. Okay, so different frequency will, or different fundamental period will affect to the different frequency. Okay, so I think I will stop now, because if I go to this unit step and unit impulse, it will take much time. And so any question for today's class? And make sure that based on what we have today, don't forget to answer this in a Padlet for the discrete time exercise. Upload your answer here. Okay. And also for week 2 over here, okay, just now we were discussing about sine wave. Okay, let's see Lee Jia Jin punya answer. Okay, so good. Just that my comment on Lee Jia Jin. If possible, differentiate differentiate between signal A and B. Which one is signal A? And which, okay, you have here X1T, X2T. Okay, that's good. So this is the correct way how to label. So make sure that you can label it either like this, or if you have different color of pen, then you can label it differently. Okay, my suggestion is that Lee, maybe you can just add now other more improvement on your labeling is that at the XT value, draw an arrow towards which signal that you are referring to. Okay, so the rest tak ada answer. Okay, one student je answer. Okay, anyway, okay, in the Padlet end of this one, I have asked one question is that based on today's question, which part you do not understand. So you just drop your question there. Don't worry if it's anonymous or if you put down your name, we will discuss it next week class. And as usual, the recording for today's class will be uploaded in Ulearn via the link later on. So So as a last reminder for all students, go to Ulearn. Go to Ulearn week 2. Make sure that you already tick your attendance. And then go to the class reflection. Okay, answer the question. Okay, for today question, because yesterday I already asked you if you want me to maintain the pace and so on. So I will continue to have the similar pace. Okay, I will try my best, but actually this pace is very slow for me. Normally I will be much faster, and we need to finish chapter 1 by week 3. So we will most probably we will take up speed by next week. So just answer the question, very simple one, what you have learned today in today's class, and that's it. Okay, so any question, last question before I end the class? Guys? No question? Okay, do the feedback form now. Fill in the feedback form now. Yeah, I just go to the feedback form. We have some time, about 10 more minutes. I want to just show to you what student answer yesterday. Okay, very good. Roughly about 56 students. So I presume that is my the total number of students for my subject. Okay, so very good. Most students, they actually able to explain in detail what they have learned. Sulaiman, Daud, okay, please do not answer only this. Maybe I don't think you entered in my class. This is the topic of chapter 1. Okay, so I do not know if you understood my class. So please write in detail what you have learned in that during that lesson. So like example, this good student will actually explain a lot of things. Okay. And I will really appreciate your reply on that. So I read all of it, and that's why some of it I pick up and I inform in Telegram about the MS team and so on. Okay, so I think very good for all students. So hopefully you guys can maintain, and hopefully but for this semester nobody failed this subject. I hope nobody failed this subject. Let's do our best, okay, from my side and from your side. Okay, that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.